Here are solutions to homework set number 4 for ECE 461-661 control systems. This homework set looks at block diagrams, canonical forms. That's it. First problem. Here's a block diagram. Find the transfer function. There's a couple ways to do that. There's the shortcut and the long way. Let's start with the shortcut. The shortcut would just say the numerator is the gain from x to y. And here's the path. That's just ABC. Over 1 plus the loop gains. So here's one loop, ABE. Here's another loop, BCD. Here's the third loop, CF. I might get a little suspicious there's a problem here. This is actually two cascaded systems, so I might be missing a term. Turns out we actually are. If you do it the long way, I define the output of each summing junction to be a variable m and o. M is x minus EBN. N is AM minus dy. P is minus Fy plus Bn. Y is C times P. Do a bunch of algebra, grind it out. Work out the transfer function. Time passes. And eventually you get this. That's almost the same. I was missing that term right there. Where that comes from is actually have this system cascaded with that one. When you multiply the two transfer functions together, I get 1 plus ABE. And the second one, 1 plus CF in the denominator. Multiplying them, I get the product of these two terms. That's where this comes from. So the shortcut usually works. It sometimes misses a term. That typically happens when you have cascaded systems. Problem 2. What's the transfer function in this case? In this case, let's take, I've got two cascaded systems. Treat that as two systems multiplied together. So here's one path. This is one loop. That's AB over 1 plus the loop gains, 1 plus ABE, times C over 1 plus CF. That's one path. And here's the second path, plus D times C over 1 plus CF. So that should be the answer. Noting that there's actually two systems cascaded, treat that as two separate problems. The long way is take each summing junction, call that a variable. So we get M is x minus E, B, A, M. N is D times x plus B times A times M minus F times Y. And y is c times n. Doing some algebra, solve for m, substitute, plug it in, do some algebra, simplify, time passes. Here's my answer. Turns out that's exactly the same answer as my shortcut. Put over a common denominator, you get that. Problem 3 looks at canonical forms. I have a third order system, represent that system two different ways. There's actually an infinite number of ways of doing it. Just pick two. If I did cascade form, I'd have three first order systems, s plus 2, s plus 3, s plus 4, feeding it together. This feeds it all together, and my output is the output of the third system, 1. I could put it in controller form, multiply everything out, and in controller form, it's 1 on the opt diagonals. Here's the denominator polynomial. Here's the numerator polynomial. Second way to represent it. And there are other ways to do this as well. You can do Jordan form, observer form. There's an infinite number of ways of representing a dynamic system in state space. Here's two of them. Problem 4 is given a block diagram with integrators, summing junctions, multipliers. Find the transfer function from R to Y using state space techniques. So in this case, I'll make the states the outputs of the integrators, x1, x2, x3. The input are the derivative of the outputs. The equations then are how to create the input. So sx1 is 7r minus 2x1. Sx2 is 8x1 minus 3x2. Sx3 is 9x2 minus 4x3. Kind of go backwards through the arrows to see what makes up the derivative, the input to the integrators. The output then is y is 10x1 plus 11x2 plus 12x3. So here's the equations that describe the system in matrix form, or state space form. Call the states x1, x2, x3. Here's the first equation. Sx1 is 7r minus 2x1. Sx2 is 8x1 minus 3x2. Sx3 is 9x2 minus 4x3. And y is 10, 11, 12, x1, x2, x3. So here's your A matrix, B matrix, C matrix, D matrix. In MATLAB, as long as we have the controls or signal processing toolbox, I can find the transfer function. Here's A, B, C, and D. Input that into MATLAB in state space form, then find the transfer function, or factored form in zero poles gain form. The last problem is repeat, given a different system in block diagram form. What's the transfer function? Here I'll make the states the output of the integrators. The input are the derivative of the states. So Sx1 is 2r minus 4x1. Sx2 is x1 minus 6x2. Sx3 is 4x2 plus 5r minus 3x4 minus 8x3, and so on. Gives you your equations. The output is just x5. Put that in matrix form. So making the states x1 through x5. The first equation, Sx1, is 2r minus 4x1. Sx2 is x1 minus 6x2, and so on. Here's your A matrix, B matrix, C matrix, D matrix. On a test, that's where you would stop. On homework, I have access to MATLAB. I can find the transfer function. Input the A matrix, B matrix, C, and D into MATLAB. Throw it into a system in state space form. Find the transfer function. That's the transfer function. Here's the transfer function in factored form. So that is homework set number 5 for ECE 461.